start off with, thank you everyone who's engaged so far with our community forum and those of you who are interested in being a part of this webinar. Today we're going to be doing a design of members for a post and beam office building presented by none other than Adam Jones. So the structure for today, obviously this is the opening, and I'll take you through just a few slides briefly. That'll cover the goals of the webinar series, the goals of the community forum, and who we are. Then we'll go through a technical presentation from Adam. We'll have a Q&A, and then we'll finish. So you'll notice it's a pretty intuitive platform that we're using here. You can see in the chat down the bottom, there's a Q&A button, there's a chat. Feel free to drop your questions in as you go. We'll facilitate it at the end. Feel free to drop any messages in the chat as well. I'll definitely be chatting back to anyone who says anything. Jokes are, of course, always welcome from my point of view. So, what is the actual goal of this webinar series? So, we're trying to keep you up to date with the platform. We're trying to educate you on how to use CLT Toolbox. And of course, we're trying to help grow the mass timber industry. So, this is the bet and the belief that all of us have, is that the mass timber industry can be significant and cause change. And so we want to continue to try and help drive that, and appreciate everyone who comes along to join. So, what is a community forum? You see, I've got this little reminder to remember to play the video. What we're hoping is that, this is a space where, we'll let the video play actually. It's a space where you can engage with each other. We can ask the community questions. Shout out to anyone who's posted in there already. Adam keeps on joking that I'll buy a slab for anyone who posts in the community forum. It continues to be true. And it's a chance to ask questions about CLT Toolbox. So, we try to be anti-fragile. We believe that we want honest feedback. We're not afraid of you airing dirty laundry on non-working calculators in the forum. It helps us address things more quickly. We'd rather share the problem together than get it in the background. So, really encourage everyone to be in there. Just briefly, if you haven't met us yet, you may have seen a lot of photos of us from around the world, a rather eclectic group, but we are actually a 45-person team. We're based around the world across Serbia, Ethiopia, Melbourne, and Indonesia, and we are one of the biggest teams in the world building mass timber software. So we're really committed to this mission. Our whole lives are based around it now. Ultimately, we're trying to grow the pie of mass timber, and we'll keep on saying that again and again, because we consider ourselves all to be collaborators in this industry. The fundamental challenge that we see is that without design and education and design infrastructure, everyone who's trying to become a timber specialist, it's just a long and costly journey on the road to get there. And so we believe, and that's part of what today and the community forum is about, that by leveraging the computation routines solved by other experts, new engineers can begin from a better starting point, and we can actually have a crack at growing the overall market. So before I head over to Adam, I, of course, just want to say thank you to our partners. We would not be here without them being a part of that journey. We've only been around for 12, 18 months, and you can see that this number has been growing really quickly. So I just want to say thank you one more time to everyone for coming along today. I'll come back to help facilitate questions at the end. I won't buy a slab for anyone who puts a question in here, but the community forum we're on. So thank you again to everyone, and I will hand over to Adam now to start his presentation.
Woo. Thank you, Ringo, and good morning, everyone, and thanks for joining us for the very first webinar series. I used to do this with Wood Solutions, so it's cool to circle back. Me and Ringo, we didn't coordinate this at all, but specifically, we didn't even talk about Ringo buying slabs. But I reckon there's one. If anyone was to comment on Nick Hewson's comment, Nick's a legend in the industry. So let's try and not leave him hanging, and that's maybe something that Ringo can send out. So so where I'd like to start is what's new in CLT Toolbox. So part of this webinar series, we're doing updates monthly. So we're going to run through that at just a very high level. So we've got new connection details, beam to beam connections, beam to column, basic screw connections, and slab to GLT beam connections. We updated our half flat butt and spline joints to allow for continuous and discrete options. And we've had the new Eurocode implemented as well. So you can choose A1720, new Eurocode, current Eurocode, or the supplier ETAs. And we've also done add your supplier, add your own grades, and manage projects. So that was one release at the start of January. And then just this week, we've released the new wall calculator, column calculator, and beam calculator with a new UI. So I guess that's like 5 weeks into the year of some of the things we're going. We've also got a new PDF engine. So that, to be honest, is a small step backwards in the short term. But in the long term, it means we're unlocked to do customizable PDFs. And the PDF functionality is going to get much, much better. And we're going to have the ability to like add comments on PDFs and things like that because we've moved to this new engine. But it's just a small hit for 2 weeks of, it still calculates and prints perfectly. But yeah, as I said, just in the short term, it just doesn't look as great whilst we redo the designs and everything like that. And then within the next 3 releases, we're going to do upgrades to the 6 dowel calculators as simple connections. We're also releasing moment connections for dowels. You can see here the steel to CLT connection details are starting. So we have 3 teams. One is the connections team. The other is the members team. So the members team, the biggest priority or the biggest gap in our platform right now is the analysis, basically. So having cantilevers, point loads, load superposition, stuff like that. CLT floor penetration, so you can dynamically move the hole in the CLT and it'll use the grillage method to design. TCC, rib decks and studs. And then features, I mentioned export, improving our PDFs and APIs as well. All right, so today's webinar, we're going to be focusing on design of members for a post and office beam building. We are going to be using CLT Toolbox to design the calculators, but with any building, it's good to look at the big picture. And I think sometimes optimizing a design for the wrong design isn't the right way to go about it. It's a bit like straightening deck chairs on the Titanic. The most important thing is to get the design principles right from the start and then fire up CLT Toolbox or use CLT Toolbox to help get the right design principles. So before we get into the design of the commercial office building, we've got 6 different ones. And this will drive down the cost of the mass timber project and obviously be more competitive against the concrete and steel one, which we're all about. So one is, as much as we can, standardize as many parts as possible. So from a manufacturing point of view, think about the Model T. Well, the car industry was before the Model T and it came along. And with that standardization from a factory point of view, it's much easier to drive throughput when there's that predictability, and better performance of factories drives down the costs of the design of your building. So when it comes to mass timber, as much as possible, think about the billet sizes of CLT and GLT being consistent. Even steel plate thicknesses, like where you can, try and be consistent. Screws, you might choose the same screw type and same diameter screws and then optimize on the spacing. So, and that's easier to install with and things like that. And to go along with that is, we can't really standardize parts within the building if we don't have standardized demands. So where we can, having consistencies in grids and the actual utilization of our elements will go a long way for that. Another one is, think of bottlenecks. So these 2 trucks have the same volume and have the same meters squared of install, but there's a big difference. So on the left-hand side, you've got a lot more different parts. Each one of these parts is an individual QA of a panel. It takes the same time to install a big panel or a small panel. There's more fixings costs, which I see Greg's on this webinar from SPAC, so he'd be happy with that, but obviously the client, maybe not as much. And yeah, you compare it to this. So big parts is always better from everyone, manufacturers, installers, installation speeds and things like that. So where you can, think about that and where the bottlenecks are. So if size is a goal, what is the limiting factor to generate as big a size as possible? And typically it's on the transport capabilities, and where you can, maybe upgrading the investment in this area might yield net benefit over a project. And with that, the best people who know the bottlenecks of everything is, of course, the supply chain. So there's that challenge of do you keep that supply chain tension and not speaking to a supplier. There's like that train of thought, but then the trade-offs of not engaging a specific supplier early are high. The mass timber industry in general is a very trustworthy bunch. A lot of them aren't going to squeeze you. Well, no one's really going to squeeze you if you do lean into someone early, and you can get the benefits of knowing what they produce and designing in a certain way. And with that, it's knowing where the costs sit. So for some projects, you can see here the CNC fabrication versus the feedstock. So there's this idea of like the idiot index. I don't know if anyone's heard of that, but it's like how much more expensive is the design compared to the raw material costs means, the idiot index, it's called. So it's like where the closer we get to raw material costs is like the closer we're getting to optimal designs. And finally, well, I think I've got two more before getting the webinar. Design it right. So when it comes to timber, the first time you get a project and you design in the paradigm of, say, concrete construction entirely and then try and shoehorn the mass timber option in, the project's going to be a disaster. And the whole project team will probably never come back to the timber option. But level 3 is like understanding, starting from the throughput of or the constraints of the supply chain, and then designing with that. And then with that, you can actually get something that's more sustainable, better for humans with biophilia, and better for developers and builders from a cost point of view. And if you hit the triple bottom line, then it's an absolute no-brainer, and that's what can help really drive the industry forward. My final one is holistic pricing. So if we can actually drive the cost, we could actually capture the costs as best we can. And preliminaries reduction can be 12 to 15%, and that's by build speeds can actually go up to 80% faster if you're not bottlenecked by any like wet joints or anything else on site. So you can build much faster and get all the benefits that go with that. And here's a bloke. He tried to put a tent up and he wasn't happy with his holiday. And this other person got a holiday in Tahiti or something and had the best time of all time with their family. So the point here, a holiday is not a holiday. They're not equal things. And a phone is not a phone. And it's also the same with building. Sometimes we look at the value of a mass timber building and just look at the cost differential alone, but you're actually getting a different product at the end of the day. So we need to, as best we can as engineers, articulate that to the clients. All right. So there's a bit of a preamble before we get into the design of a commercial post and beam office building. So this is a pretty perfect design from an engineering point of view. Obviously, the real world is a bit messier than this. But looking at the grids, we've got, say, a 6 meter by 8 meter grids, and then you've got a centralized core, and the dotted lines here meaning your lateral K-bracing. So in this webinar, we're going to be doing the basic member design based on the new calculators on the platform. But in the next webinar, we will be looking at more lateral stability and connection details. And time permitting, I might give you a sneak peek at some of the connection details as a teaser for the next webinar. All right, so let's get into it. So we're going to start with a CLT floor design based on the following parameters, and we're going to look at different vibration methods and the impacts of it. So maybe Ringo, if you're happy to put the register now button into the app, and then most of the calculators today are on the free version actually. So feel free to play along at home as much as you like. So Ringo, if you can share that in, then that would be good. Or everyone can just like register through the website. It's pretty straightforward. So you can see here the platform. If it's new to you, you've got, well, this is a new UI update we've pushed this week. So before we used to have bigger containers, more clicks. We've reduced the amount of clicking available. We've dropped the beta tag on some calculators as well. And we've got this new retired members section. So they've gone fishing, some of our initial calculators. We were big fans of them. You've probably seen them before, but these are still working. You can still access your old saved calculators, but it just means something better and younger has come through and is a bit more versatile and a bit more athletic. Hence, it's got the pole position on the platform. So that's members. Same with connections. You can see all the connection details, and over time, a lot of these are starting to light up and be populated. And we're going to have the connection retired here is actually a calculator on a walking stick if you're wondering what the retired connections look like. So for the platform, click a floor calculator. It's the most popular calculator. At the end, I'm going to show you how we deal with fire from now on. So for new project scope, you've got personal, or if you're in an enterprise account, you can actually put it towards a project type that everyone in your company can see it. So our enterprise customers have that option. Put in your project name. Group is for like level 1, level 2, things like that. Then the title of your calculator. We're going to go an existing design team. There's something I've created before, but I'll go a new floor calculator. Again, you can choose the levels, things like that. But let's just go level 1 floors calculation. All right. Cool. So as it's populating here, you can see you've firstly got manual input and you've got the range of grades. So you can design everything from first principles. You can do single stack, double stack, everything like that. You can design with your supply chain partners. On top of that, in the new enterprise panel, you can add and configure your own suppliers. I'm going to show you a bit about that at the end. But yeah, so firstly, you can choose your suppliers. So let's say XLAM is one option. And if you want to speak to the suppliers, you've always got the contact details there about who to chat with. I think Rob's left now, so we're going to get Jordan's name in there. Go through, you got your design codes to design with, your loading data. If you haven't seen the latest version of the app, we have added additional load cases. So as you add in wind load or snow load, you can see these loads populate, and then the default load combinations also populate. So let's just go dead and live. We've got our default load combinations, manual input forces. Moving through, you've got things like your self-weight considered, topping, and then your loads. For us, there's a 1.5 kPa SDL plus a 3 kPa live load, so we don't need to change that. Other things, you've got your different analytical methods. So extended gamma being powerful, allowable for any cross-section, shear analogy accounting for shear deformation and things like that. But a lot of you've probably been on this platform before, you're aware of this, but if you're not, you can always just go through the educational features and learn and help understand what the best method to choose is. Got your design, K-factors, and then your deflection data, and then our vibration method. So you can see here the vibration a lot of the time is what governs the design. So you've got, right now, we've got the new ability to add in the revised Eurocode, and this is probably the most advanced vibration method and allows some new things. So firstly, if you click the drop down, you can learn about the floor performance levels. We can improve this table a little bit, but you can see that the office option, you've got the quality choice of level 1, 2, 3, all the way through to the economic choice through 5. And that's based on a response factors, a different response factor based on the different floor performance. And you can see here, as we go to level 1, it doesn't work, but you can go through your client and negotiate with them what's the actual level we're choosing to, and as you fine tune that, you can actually get the costs right from a mass timber supplier point of view. It's also got now flexible supports or rigid, and that means you got supporting beams contributing it to it, so working as a system. So you can input in your beams, and as we design our beams, you can come back in and update the stiffness there, assuming we were to be flexible or rigid. All right, so you can see the calculations based on what we chose there. We can easily, again, change our suppliers, change our layups, and get the most efficient. So for us, we're a 5-layer. If you were speaking to the client, if you had to have more stringent vibration requirements, you can see here, as we get to 7 layers, you can expect a higher cost. So, you could sit down with the client and say, look, if we have this vibration criteria, then we can get away with a 5-layer panel and not have to lay up 7 layers in the factory and save costs and things like that. All right, so going through, you've got all your different different calculations in detail here. You've got your loading combinations, so here for dead and live, but as I mentioned before, as you add in snow or wind or whatever, all of these now update to be the default load combinations to match the scenario. And that's something, that's been in the last month or so. You got your different loading combinations, so bending moment. And I mentioned the new analysis is coming in to give you that extra power there. And then vibration as well. You can look at it in detail. You can follow the specifics of it all. You've got the natural frequencies, and this is dynamic. So the calculations go deep and detailed because vibration is the critical factor. It is okay to go in this circumstance, but You can see here as you go with flexible support, it does update dynamically based on the conditions. And for us, that's where a lot of the time goes into, is changing all those modules that we have based on the scenario of what the user chooses. So going through, you got your design, and at the end, you can hit save, and we've designed our XLAM panel. All right, so that's a CLT. At the end, I'm going to design it for fire, because we've got a new fire module in progress. It's just about to be released. It's taken us about 12 months to get there. All right, so next we're going to design a beam. So I've gotten a little bit messy here, but let's just start a new calculator. It's now called a timber beam. It'll make sense why soon. So, floor 1 beam, something like that. So here you can start the calculations from this level, and maybe at the end I'll show you a few more things at the project level that sometimes gets missed. So here we've got GLT. This is our new timber beam calculator released on Monday. Why it's exciting is because now you've got GLT LVL and sawn timber as well. So it just shows over time we are incorporating more and more of the broader categories within the supply chain. And again, you've got the different designers here. So for us in this case, you can design for Australia, local, European supply chain, whatever it might be. So we can start populating our beam, whatever it might be, knowing we're going to design penetrations later. You might start with your penos and work back. For our design code, we might design to Eurocode in this instance, so 750 by 400. We can go back and optimize. For this case, you've got your same outputs, your dead loads and your live loads. I think we had 18 and so 15 here and 18 for the loading, whatever it might be. Analysis data for us, it's a 9-meter span. For the beam, we've got explicit shear deformation calculations in there right now. So that's for CLT, it's captured in the shear analogy method, but here it's an explicit drop down. And sometimes that is the difference. As you can just tell there, shear deformation is actually not always covered at all. Like, it's sometimes considered in the too hard basket. So if you're doing a holistic design, it's something to consider. So output summary, again, got all the loads, everything like that. So if you've been on the platform before or designed the CLT floor, it's working in the exact same way. So I won't need to go through this in too much more detail, but again, you've got all the load combinations based on what was designed for in the Eurocode. So let's save our. Well, actually, I didn't get that working. So let's go 450, and reason being an FRL of which we're not designing for 5 today. We will in the next webinar of 120. And meaning you want to match the breadth of the beams usually to the column breadth. So you probably have a 450 column, hence you might play with the breadth rather than the depth, but different ways of skinning the cat, of course. So right there, we designed a beam. Next, we've got our internal column design. So we're going to design 2 columns today, an internal one and an external one based on the current, those forces put on the platform. So this is also a new calculator. So if I go timber column, and again, I should put this into groups as you build it. So level 2, level 3, that's probably your best practice on how to do this. And we're building our calculator. So other things here, you might, as you're populating the project, you can assign the task. If you've got multiple people into it, you can actually maybe add all the calculators for the project, assign them to your team, and then build it that way. And then, you could say, hey, everyone, please refer to assigned tasks. So that way you can actually do collaboration. And that's how users are currently using collaboration features at the moment. And that's when you have shared projects, or I mentioned before, at the enterprise, at the customer level, at the project level. So material type, again, a bit like before, GLT, LVL, we've got edgewise, flatwise, or both. So we do take into account for biaxial bending the properties in both directions of LVL. that's one of the things. I know other software doesn't capture that. They just put in one load of properties. So that's something to keep in mind. So for us to match the GLT we mentioned before, I think I said GLT 28 EU, 450, 450. So you can see the dimensions being populated here. Some of the other, the new elements you've got a basic structural drawing essentially of what is being designed in both elevations. So again, simple screenshots you can work with for that. For us, you got the height, say 3.5 meters, maybe maybe 3.2 or something. For lateral restraints, again, you can go multiple restraints. So you can see here, we got multiple restraints. In our context, we don't need them, but you turn it yes and no, and then you've actually got your elevation and everything being designed like that. Again, you got your Eurocode design in this instance. I showed you A1720 before. Dead and live in this case, you got your self-weight considered, service class, category of office locations. And then this is a new part as well. So the axial load above, we've got 648 and 720. 648, 720. Soon we're going to have a drop down for the eccentricity, but to be honest, that's the sort of thing you could post in the community forum, like when it's not explicit what eccentricities are a good assumption for your axial load above, you know what I mean? So it's like, feel free for someone to post that in the forum or a comment or something like that, because they're the things where we obviously don't know everything in our team. We're really good at like devouring standards and design guides, but sometimes there's nuance that's not always captured. So you can simply just turn your connecting beads on or off, and you've got an arrow here to show where the eccentricity is of that connecting beam. So right now, you can now connect the beam here and do the loading of 72 and 60. And because it's balanced, it's going to be both sides. And you can obviously play with that as much as you like to actually try and find a critical case. All right, so that's a beam connecting above and below, as is the internal column here. Next, you got your design factors, design data, and you can see all the calculations here based on the Eurocode. You got your properties, loading combinations, and analysis. So for the analysis now, again, you've got axial force, bending moment diagrams based on the column, and then in-depth calculations. So we obviously go really deep in detail with all the calculations. Some of the collateral damage of that is it's like the output summary could be simpler. So we are adding a one-page. This summary is going to be better at just giving you the very high level one-page PDF type summary, and that way you're not sending 30-page PDF per calculator or whatever it is to certifiers, which nobody wants. Yeah, like with everything on our platform, it's quite not that you'd based on what you choose, it's dynamic. So if you go to design code now, just as it's loading, you've got all of your Australian standards design. So it's modular. It's really straightforward to see what the differences are. In this case, so if it was the Australian standards, you can see here for we've got a more elaborated K-12 calculation. You can do that as calculation itself. And for K-12, we calculate it separately for bending and compression. So two separate K-12 calculations that go into detail. I think on the previous versions, we just had one type of K-12, hence old-fashioned retired calculator. So I'll put this back onto where we were. And save the calculator. All right, cool. Next, we're going to do an external column design. And I won't, so this is the design we just did, but now with the external column design, we can simply duplicate it, go external column 1, hit save. Oh, thought I lost it for a second. It's on the next page. Thank God. It's always very early days in the software. There was a lot more little things that happened unexpectedly, but good news is that's sort of on this way out. So you can see the same data presented before. You know, the only difference here is we've only got load from the top beam. You might have more of an unbalanced moment in this case, but you got less load, so 324 and 360. And not always this will be connected to your lateral system, but for the purposes, sorry, that was the other way around. I meant to go 72 and 60 here, 72, 60, and the load above was 324 and 360. And you'd expect, well, buckling, it's currently failing right now, which is interesting. So, so you'd obviously have to upgrade the size and things like that. So the other load case that we've got here is the wind combination. So you wouldn't have wind from the load above, but if you were to connect it on that actual floor, right now you can put it in as a load. So for one direction, whether it be, 6 kilonewtons per meter, whatever it might be, and you can see our elevation view updating based on the actual lateral load. So 0 in this elevation, 6 kilonewtons per meter in the alternative elevation. And when you go into your loading combinations, all of this is picked up based on the combination selected. And then also in the analysis, you can see how it's working. So for the wind combination, as you'd expect, it's more of a bending moment diagram that looks like this based on all the scenarios that pop up. All right, so that's a column and demonstrating duplicate calculator. Another one, of course, is a beam penetration calculator. So right now, this obviously can happen deeper in projects, and it's a lot of time that goes into this. We've gone through a lot of iterations and improving this ourselves. But let's imagine we've got a couple of HVACs hitting our beam, so to speak. So go to beam penetration. So beam 1A penetration. And we can load it up. You could obviously create the calculators from the front view as well. So for the penetration, here's, well, this is quite similar to the one I created. I actually saved this exact calculator earlier, actually preparing for this, but you can see the penetrations. You got a number of penetrations. So as you go through, you can change the number from 3 to 2 to 5 and so forth. And it's quite easy to work with your mechanical services provider for the project to actually negotiate with them about how to deal with your penos. Now we've got multiple. So for us, say with our depth of say 450 by 750, you can do your reinforcement. So you can make them both unreinforced or reinforced. So for us, we can just see how it's working, or it is working right now based on the location of it is. Let's see what happens if we unreinforce the second penetration. It is still working, but telling us to use a fully threaded screw. So that's the penetration geometry. Some other checks. This is based on the new Eurocode 5. And then you got your loads. So for us, we had 47 kilonewtons per meter loading. And then you've got your different service classes. So that's based on an unreinforced penetration. But let's say if we were to reinforce it, we've got our ability to change your supply, choose your supplier here. So you got SPACs. I know is on the call. So with SPACs, you can say, all right, if they're our supplier, you can go through their available screw types. So that you got all the screws here available, fully threaded, partially threaded, service classes available and everything like that. And then you can choose the screw type that matches the scenario. So with that, you've got all the screws to go with that. And if you were to change your supplier, it is easy as a click of a button. So HBS, VGZ, again, quickly learn about the actual screw families of every supplier and design with what's available. So I'm going to just keep it like this for SPAC. So I'm sure everything works, but yeah. So you can easily go around, get to the right. So the Werox fully threaded, sorry. But yeah, you can see that, I guess it's been made easy. The other thing is you can design to the ETA or the draft Eurocode, and it has the smarts there to actually give you information on the pre-drilling required, because obviously that impacts the calculations, but the draft Eurocode may not impact the calcs in that instance. So that gives you that flexibility and ability. All right, so K factors and then reinforcement data. So if we go 2 or 3, it all dynamically updates based on what's selected. So in the calculation, so this is one of the big updates we've had recently. So you can easily now see both penetrations check by check and what checks are actually being covered. So it's slightly different for the unreinforced penetration that has a tension verification. And you can see that's an additional check, the flexural verification. And then you got the actual reinforcement geometry check, not required for the second peno, is required for the first one, and the reinforcement design itself. So with that at the high level, you can look at it, but all the calculations, again, not a black box. So it's good for us because we build confidence in our platform, and if there is ever something that doesn't look right, people see it straight away and lets us know. We've also implemented green here or red, so straight away when there's so many checks, you can tell straight away where the issue is in terms of a design. And tension verification, so this is the unreinforced penetration, flexural, shear, and again, reinforcement geometry checks. It's based on the ETAs or the design code method selected. And, one of the things about designing with ETAs is sometimes that simple click of a button might get you that improved performance of that supplier. And with that, you actually, for a big project, you might save 10% on screws because you actually chose a better method. And that might save you $20,000 or something. So if you think about you trying to get big wins for your client as fast as you can, designing screws as best you can is one way of doing it. All right, where are we at? So that's a few of the most recent calculators. I'm going to go through a few random different scenarios that could pop up here. But what happens if another supplier that we haven't partnered with on the CLT Toolbox platform? So this is a new enterprise feature available to enterprise customers, but they've now got the ability to have this suppliers tab. And in this, what you can do is add your own supplier now. So you can see here in blue, the light color, this is what the CLT Toolbox enterprise account has built, just so random ones. You can see some of the demos we've had here, Stora being an example. They've got calculators. They don't really like us because we're building this probably, but you could put any data you want on the platform basically. So with that, you can add your own grades from first principles and get in the properties, whatever it might be. But most of the time we've already got the grades on our side. You click add supplier, webinar, let's go smart. Everyone's like smart LUM, maybe. We caught up with Smartland this morning, hence they're probably top of mind. Target region, let's say it's Australia. Let's say they're from origin region. You can go to the origin region, and you can do this for GLT. You can do it for LVL. You can do it for anything you want, basically. So let's just do a save as a test. Smart LUM. Edit supplier, or you can do layups. Let's just add a layup in. 90. Oh, that's a weird one. Let's go 45, 45, 45, 45, 45. Just put in anything here for width. Doesn't really impact the calcs, to be honest, because we manually input that for the shear wall calculator. CL5, 225, grade. Let's go C24. And you can see it being built up. So we're just building a CLT, any CLT in the world you've got now, and you can add them in for later layups. So even for mass timber suppliers, it could be really cool from an R&D point of view. When I was working at XLAM, this would be amazing to just what's the most efficient layups that we can think of, and see what the implications are in design, what are the savings and everything like that. So there we have it. So we've got the details right there. We've got Smart LUM, you can edit supplier, you can put in details yourself, everything like that. But let's go back to our company project. And we want to see what the impact of having this supplier is. So let's go back to here. we've got the floor, which what's today's date? I think this is registering yesterday's time, but let's duplicate this. Let's go new. What did I press then? Sorry, I don't know where that went. Let's go new EU. Sorry, that's a bean. CLT. Duplicate new EU floor supplier, whatever it might be. Calculation duplicated, and then we go to our EU option. We designed for AS1720 before. And where is it? Smart LUM, there we go. Got Smart LUM, got the EU. Again, choose the design code, and then it's going to be designed based on everything just went. For our vibration, we're on the Hammerdale method. Go revise Euro code, level 4, and it's working. So that's one of those things. So it just gives you that. Same with LVL, you might want to keep on the platform, whatever it might be. All right, so we've probably got time to just give you a sneak peek of some new things on the app. This is coming next, and which is really exciting. So I will, where's the best place to do this? So this is available for me as an alpha calculator and testing. If anyone's like really wants to be part of our testing and stuff like that, just let us know. We could probably give you the alpha tag as well. It just needs to be known it's not in a stable environment. But add calculator. So this is where it's going to be able to share the data. So, I'm going to go to the, please forgive me, I'm going to go to the dev environment just because it demonstrates it more fully. All right, so we've got multiple branches. So the way that software works, basically, you've got little twigs, which is like one software developer's work. Then you got branches. Then you got big branches, and then it's trunks. And it goes from the most outer twig and branch, and then it keeps getting pushed into an app release, which is like the trunk. Hence, I'm going further out than where the tree trunk is right now, just to show you the latest version. It's a bit more unstable, but it's more advanced. So let's get our design going. So same as before, you've got all the design checks from a non-fire point of view. But now all you're going to do is add the fire scenario. There's a lot of calculations, so this just does take a little bit longer to load up. Yep, you can see it here. So you got right now it all speaking to each other in the right way. So for us, let's just do our FRL of 90 minutes. For char rates, you've got the calculations in Eurocode, or you can do manual input. You got the ability, like before, to do glue line integrity, things like that. So this is in, so you can see that working. But probably the most exciting is you can actually add as many layers as you want. And based on fire tests, you might, for example, have whatever the protection layers are. You can do screed on top. You can do whatever it is. So you've got insulation as an option. When it gets pushed to app, it'll have, mineral wool insulation, everything like that. And you're actually building up your layups dynamically. And that means you got your acoustic system contributing to the fire, which is the reality of a lot of the time. So, and then when you go to the calculations, it just reruns it all. So you got charring calculations in detail. You get the end of fire cross-section to recalculate the panel properties. So you can see here, it's designing based on a 5-layer panel in between, so 1, 2, 5. So it just recalculates it based on the new sizes. Does the loading combinations based on the fire case. Does the analysis based on the fire case, and then it redoes the design based on the fire case. So it is really comprehensive, and the good news is you don't have to. You can share data across the non-fire and fire case right now, and easily see what's governing. In our scenario, vibrations governing. But you could easily imagine, right, if you. Hopefully this works on the fly, it's on the dev environment, but if you could easily imagine if you reduce your fire layers as such, change the FRL to 120, whatever it might be, that balance between, assuming this actually, so that's probably closer to, after the zero strength layer, it probably gets closer to a 3-layer panel. It's still working right now. Let's just make it, actually, because it's on it's on protection time. So yeah, you can manually input your protection time of each layer, or you can calculate each layer. So with that, yeah, now it's a 3-layer panel, and you can just follow how much is burned through. So right now, it's still working. So that's like still in dev, but once that's going through, you can easily balance the design from both scenarios. Great. Well, for the final step in this demo, I might just show quickly the wall calculator. That won't be in the next webinar, but this is also, I've showed you the new beam, the new column, the new floor, but the new wall calculator, again, save it to whatever project you want. Let's go Languish Hotel. I wonder, that must have been not a good day whenever I came up with that project name, but anyway, let's design Languish Hotel. Yeah, with this design, you can see again, you've got basic cross sections now every time, so it's a much more powerful calculator, I'd say. Again, design codes, analysis, similar to before, you got framing of platform or balloon. But now what we didn't have, you got wind, so you can do outer plane wind loads, whatever it might be. Eccentricities, you got manual input, but now we've built in the revised Eurocode. So this is what governs the design of walls a lot of the time. And again, you can always go through and learn from it. So we are building in CSA, Canada, and USA as eccentricity methods as well, similar to vibration, because it does govern more than you'd expect. So for us, we put in the wind. You can put in the load there, and then go through the calculations as such. So that's just a quick sneak peek at the wall calculator, but we might leave it there, and I'm going to stop sharing now because I know it goes weird otherwise. And good to see you there, Ringo. You're always nervous when you stop sharing that you've been presenting the whole time, but your internet dropped out. That's happened to me twice. In the webinar context.
No, woo! Well done, man. That was awesome. We actually did get a few questions, so we will get a chance to go through them. But I'll open by saying, yeah, Languish Hotel doesn't sound like a particularly pleasant place to stay.
It's really when the release is going late, I guess. When I was doing the final testing,
up late at night. Yeah. I'll also open by saying Jason McCall with the awesome last name said that the beam penetration calculator would have saved him a lot of time on some previous projects. But then there are some interesting questions here, I think, about analysis conditions. So I think, so I think maybe I'll just ask them one by one, and then you can give an answer. So
you can click Spotlight, Ringo. Just on the Spotlight, that'll pop up on the screen as the question. There we go.
Great. Oh, that's awesome. All right. Is there provision for seismic loads?
Yeah, so we couldn't on our calculators, you can input the factorized forces and loads. So in that sense, it does as an input force and then design. But we're not a FEM software, so a lot of the time the seismic will be taken out of our platform, and then you can input those loads and forces from a design point of view. So and the new Eurocode I know does have much better seismic provision. So that is on the backlog. Marco, our product manager, knows a lot more about it. He joined that presentation when we were at Innsbruck last year. So over time, we're going to be more complete solution for seismic as well.
Awesome. All right. I'll click that as answered. The Spotlight's awesome. All right. Another one. Fazil again. Don't see cantilevered beam option design.
Yeah, that's exactly right. And that's to be honest, there's some things that we get asked all the time. It's like a clear gap that we've got and an Achilles heel. But the good news is that is the number one priority on our side to update, basically. And a fully fledged analysis module. I'm trying to in the background get up the latest version of it. I should have prepared with that. But yeah, so you can have the ability to add point loads as a cantilever, multiple loads on the one beam, and have differing loads, things like that, and up to like 4 or 5 spans, up to 4 spans, cantilever both sides. So you're going to have that full functionality and flexibility that I think everyone's been wanting for ages. So that answers that
I
one
think
as
that's
well.
the nature of the next question. Yeah. Well,
That's fair
okay
enough.
then.
And that'll be wired up with, even the fire. Where it gets interesting is like wiring that up with the fire calculator, because you see you got non-homogeneous layups with the likes of like XLAM with MGP6 in the middle. So as you have the moment on the top and bottom for unequal spans and reading it properly. So we're just like wiring it up as well.
Yeah, similar. I'd assume your answer there is related to this question or this comment too. And here's one from Matt. So this is about the collaboration features.
Great. Matt Fraser. Yeah, if you have a team of engineers with a shared project to show that users who sign the task. Got you. Yeah, we don't have completed or unresolved yet. So good question. And maybe that's one of those easy things we could implement, but we just haven't put it in yet. So probably in the meantime, actually, having said that, what would in the software, if nothing's been saved yet, it'll say no data at the end and when you print it. And then
you also,
go ahead.
Well, yeah, while you pull that up, it's also the functionality is that if you have a project with a set of calculations, you can assign calculators. You can assign those individual calculators to different users, and their name will pop up next to the actual calculator itself. So you could look at 10 calculators in a project and it would have a different name next to each of them, and then you can comment in the project itself and tag each other in there as well. So that's version 1 of those collaboration features.
Totally.
You're going to pull something up?
Maybe is it worth it? Just because I think the analysis this might be an old version of analysis, so just bear with me, everyone. But it gives you a flavor for how we do it. Like we build Excel prototypes first, so you're going to be able to put in the span length, do free, pinned, and the types of support. But yeah, up to 4 spans, and then this is something that was from like a while ago, actually. So December. So so you do have 4 spans, free support both sides, UDL point load add in, and stack the loads like that. So that's like a bit of what the UI will look like, and that'll be just basically one drop down as well. No,
infinite. We've got a few more questions actually. This is awesome. I'll just get to you again, Faisal. Here we do have red stag in the software, so if you sign in New Zealand, they're there. As a New Zealander, I'm obviously quite happy about that. And then we have a few anonymous ones. So this is a nice thing to say. So
yeah,
Adam.
Yeah, gotcha. So the DAOs right now, so that's currently got just simple connections, and based on the new Zealand code, draft Eurocode and the existing Eurocode. And but yeah, the next step, there's 2 next steps. Step 1 is in 2 weeks, we're going to re-release the most popular 6 DAOs for a better user experience of just the simple connections of just actual loads, basically. And but in parallel, we're quite deep into building our moment connections out, and that will just give you much more flexibility. To be honest, the user experience of our DAOs at the moment aren't the easiest to work with, I think. So we're just like going back to the drawing board based on a lot of our users and building like really good moment connections, because they're the things that are like quite difficult. Okay.
Yeah. Here's another anonymous question. Is there a way to tell how far away the calculations that haven't been released yet are? That's a great question. That's something I care about too.
Yeah. So on the website, just trying to think if
I don't think it's live.
can you just so the new pricing page on the website is going to have the roadmap basically. So I'm just trying to stall a little bit whilst I keep that up. So we're about to release
while you pull it up, it's worth noting, like you can always email us, of course, and just ask if there's things that you're wondering about, but obviously you don't always want to have to talk to a human about that. But yeah, continue on. And
so the new pricing, we're going to update this weekly soon. So it's like the features ETA. So you can see here the new PDF 1 page, ETA March, bulk inputs for the API beta program, what's the enterprise, free, pro, everything like that. You can see portal, light frame shear walls, diaphragms, what's ready, things like that. So we're going to, because we get asked that all the time, as you can imagine. So we're going to the new pricing page should be up in the next week or so to help with that.
Yep. We've got a few minutes and more questions coming, which is awesome, by the way. So we'll try and rocket through these next couple. Adam, this looks like
Here's a good question. Yeah, so reinforced timber member design. So we're going to have a shear reinforcement calculator. This may not answer your question perfectly, but we've got, say, the reinforced beam notch calculator. We've also got timber beams with shear reinforcement. That's coming soon, but maybe if you want to, feel free to post in the community forum as well, like if you want to know what specifically, and then we'll come back with detail, and then you might suggest something different, to be honest, and then that way we can keep trying to build something that's meaningful.
Exactly. And first post in the community forum gets a slab as well. And we've got another one. So Westbeam, we don't have Westbeam's products in there yet, but there was obviously the section of this presentation where Adam showed that you can custom configure products from virtually any CLT, GLT, LVL supplier. So you have the ability to have the ability to configure them and use them across your organization if you're a paid user.
Brian, if you don't mind, I might screenshot this and send it to Wesbeam, because we've been last time we spoke to Wesbeam, the LVL wasn't ready. We haven't spoken to them since we've actually had LVL properly on the platform. So it's probably a good nudge for us to get back chatting to them again. But that's a good instigator, Brian, if you don't mind us sharing that screenshot.
Someone waiting for portal frame member design and related connection. Great to have custom. Yeah, a lot of 100%. I'd say portal frame. I'd say that after advanced analysis, portal frame and timber concrete composite are probably the two most commonly asked for or excited about things when we demo to people.
Yeah, 100%. The portals as well. That's we've been working hard at doing that in a smart way. I think there's like good steel portal software out there that means steel's got the whole market, but and everyone needs to do a detailed design to get a price to do the portal frame. So just right on that, it just doesn't add up. So we're super excited to get into portals.
Yeah, I just pulled that up to say, Brian, we're glad you brought it up too. So, we're partnered with a lot of the producers. So as much as we can, show to them and to both sides that there's value on them being on there and value for the engineers being on there, the better. So appreciate you bringing that up. We've probably got room for one more question. If anyone wants to, I think Adam said he was open to existential questions as well, completely unrelated to Toolbox. I don't think so. So I think I'll just say thank you to everyone for coming along. This is obviously our first one. The slab on offer remains. We really appreciate it. The recording of this demo is going to go up. This webinar, is going to go onto the community forum, so you can watch it back and share it around. It should be really nice and easy in that sense. We're always so happy to hear from anyone and everyone. We really appreciate the feedback that we get from the industry as a whole to improve the software. So, Adam, any final words?
That's it.
Chance of
Jason. Thanks everyone for joining.
Yeah, Jason, work in progress. So we'll send them that too. Thank you, everyone. Have an awesome day, and we'll catch you all soon.